So derivatives of functions in parametric form. What is parametric form? When we are finding, suppose dy by dx, if we have to find dy by dx and y is a function of t, y is a function of t and x is a function of t, another variable, then in this case, how to find the derivative? dy by dx we cannot directly find because here this is the function of t. So dy by d, how we can find dy by dx? Dy by dx first derivative we can easily find out. We can divide by dt because it is the function of dt, dy by dt and dx by dt. And here y is a function of t, then we can put the value of y. So we can get d by dt of function, whatever the function is given, ft, and d by dt of dt. Like this, we can find first derivative. And how to find second also, I will tell you. Okay. So let's take some questions for one first derivative to find the first derivative. For example, okay, I'll take one example, then we can start exercise also. So this is the question. Find dy by dx when x is a function of a cos theta, means function of theta, and y is a function of theta. So as I told you that we have to find what we have to find. We have to find the derivative dy by dx. Dy by dx. But y is a function of theta, a sin theta, and x is a function of theta, a cos theta. So we have to divide by d theta because both are the functions of theta. So dy by d theta, dy is divided by d theta, dy by d theta, and denominator is also divided by d theta, so dx by d theta. Now substitute the values of x and y. So we get d by d theta of y. Y is a sin theta. A sin theta divided by d theta of x. And x is what? A cos theta. Okay. So a is constant. So a will come out, and sin theta, differential of sin theta with respect to theta is cos theta. Similarly, here also a constant, and differential of cos theta is minus sin theta. So a and a will cancel. You get minus cot theta, cos theta upon sin theta, cot theta. So we will get the answer in theta. So it is a function of theta. This is called parametric function. Okay, got it? So we have to find second derivatives also in these cases that we will do. Okay, no, not now. So we can start our exercise. Five point six. This question we have done just now, second question, first question, third question, fourth question, fifth question. All are easy, but only from here you can see that somewhat complicated functions you will find. Otherwise, all are simple functions. What to take? Okay. Question number 5. Cos theta minus cos 2 theta. Sin theta minus sin 2 theta. Find dy by dx. You can find separately also, as you have given y is equal to sin theta minus sin 2 theta. So you can find dy by d theta, because we have to find dy by dx, and that is equal to dy by d theta on dx by d theta. Here we have to put the values. Question number 1. We can separately find out dy by d theta. To differentiate with respect to theta, we get dy by d theta is equal to d by d theta of this. Because of minus, d theta will go inside. So d by d theta of sin theta minus d by d theta of sin 2 theta. So differential of sin theta is cos theta. And here you have two functions. First, outermost is sine. So differential of sin theta is cos 2 theta, and differential of 2 theta is 2. So 2 cos 2 theta. Okay. And now you take y is equal to x cos x is equal to cos theta minus cos 2 theta. And again differentiate with respect to x. Differentiate with respect to theta, sorry. So dx by d theta is equal to d by d theta of cos theta minus d by d theta of cos 2 theta. So cos theta, differential of cos theta is minus sin theta, and cos theta is minus sin 2 theta, and differential of 2 theta is 2. Your third. So from second and third, using second and third in first, okay? Using second and third equation, from second and third, put in equation number 1. So we get dy by dx is equal to dy by d theta. Dy by d theta is cos theta minus 2 cos 2 theta divided by minus sin theta minus 2 sin 2 theta. You can take this minus common and multiply that minus in the numerator. So this will become sin theta plus sin 2 theta. 2 sin 2 theta. And that minus will multiply here. So this will convert to cos 2 theta minus cos theta. This will be the final result of this dy by dt. Sometimes they are using the formulas for cos 2 theta, sin 2 theta to simplify more, so it depends. Okay, so we have to find dy by dt. Here it is the function of t. So first we can find dy by dt and dx by dt. So dy by dt, dy by dt is equal to d by dt of this function cos cube theta, cos cube t upon under root cos 2t. Is the function of t, that's why we are differentiating with respect to t. We have to find dy by dx here. So dy by dx is equal to divide by dt. So dy by dt upon dx by dt. These values we have to find out and substitute here. So dx by dt, dy by dt first we are finding. So we will use quotient rule. Here you have to use the quotient rule. So denominator, leave the denominator, under root cos 2t and differentiate the numerator. Now we will differentiate directly. Cos raised to power 3. So 3 cos square, differential of 3 x square, so 3 cos square. Then cos t, differential of cos t is minus sin t. Got it? Chain rule. Cos cube t, we have outermost is power. So x to the power cube, the differential is 3x square. So that's why its first differential will be 3 cos square t. Then inside cos t, so the differential of cos t is minus sin t. Therefore, minus 3 cos square t sin t. Then minus, leave the numerator, that is cos cube t, and differentiate this under root. So how to differentiate this under root cos 2t? So how many functions are there? 3 functions. One is root, another is cos, and then 2t. So root, differential of root, as I told you, differential of under root x is 1 by 2 root x. 1 by 2 root x. Differential of x is 1 by 2 root x. So therefore the outermost is root. So differential of root will be 2 root x. So 2 root cos 2t 1 by. Then differentiate cos. So differential of cos is minus sin 2t. Then differential of 2t is 2. Okay. So this 2 and 2 will cancel. We get minus sin 2t upon under root. So we can write here minus sin 2t upon under the root cos 2t and divided by the square of denominator, that means square root of square root, that is square root will cancel. This square root will cancel, cos 2t will be left. And then again, if you simplify this cos root t, this minus minus will become plus cos cube t. This sin 2t we can write 2 sin t cos t. And here when you multiply under root cos 2t is the LCM, this will multiply with this one and that will come in the denominator. So that means it will become denominator, this square will make it cos 2t, and then if you see in the numerator, this is under root cos 2t, you will take LCM. That LCM will come here under root cos 2t. That root and root will become cos 2t. And here you have minus 3 cos 2t. This cos 2t can be converted into cos square. So we can write cos square theta minus 1, cos 2 theta is equal to cos square t minus 1. And this cos square t is as it is cos square t into sin t. Sin t. Then minus plus, this will become cos cube t. And this sin 2t, 2 sin theta, 2 sin theta, cos theta, sin 2 theta is equal to 2 sin theta, cos theta, sin t, cos t. We can write sin t, cos t. Okay. So at last, we got minus, this will become minus 3 cos square, minus 6 cos square, minus 6, yes, cos square t, cos square 4, cos, yes, cos s to power 4. So this will become minus 3 to the 6 and minus plus 3. Okay, so we can multiply inside all these terms and write down. So minus 3 to the 6 cos square into cos square cos raised to power 4 t into sin t. Multiplying this term inside and this minus 3 also inside and writing. So minus plus minus, then minus plus 3 times cos square t sin t. Then this will become 2 times cos raised to power 4 t sin t. And denominator is as it is. Denominator is not changing. We can write denominator as it is. Denominator is cos 2t under root cos 2t. Now you can see this is positive. We can write first this term 3 cos square t sin t first. Then these two are like terms, minus 6 and minus 2. Okay. And so minus 6 plus 2 will become minus 4. So that will become minus 4 cos raised to power 4t into sin t and whole divided by cos 2t under root cos 2t. Okay, so this is only dy by dt. Similarly, dx by dt, you have to find dx by dt and then substitute here. So dx by dt means you have to find d by dt of x. X is sin cube t divided by under the root cos 2t. Same procedure is applied here also. Okay. So denominator as it is under root cos 2t as it is. Then differential of cos sin cube t. So 3 differential of sin cube is 3 sin square t. Then differential of sin is cos t. Minus. Now sin cube t as it is numerator differential of root will be equal to, I will write directly, this will become sine 2t and root cos 2t. And minus will also come, so that minus will become plus and root cos 2t. And denominator will be as it is square of the root, that means cos 2t. Now again multiply, and this cos LCM you will take, this will become cos 2t. So when it will become cos 2t, so you can write cos 2t. Now convert into sine, 1 minus 2 sine square theta. 1 minus 2 sine square t, and this 3 cos sine square t, 3 sine square t cos t as it is. And this will become plus sine 2 theta, you can write 2 sine theta cos theta, and sine cube t as it is, sine cube t into 2 sine t cos t. 2 sine t cos t, cos 2 sine t cos t, all divided by the same value cos 2t. Then multiply and solve, and at last you will get the final answer as 3. You can check 3 sine square t cos t minus 4 sine raised to power 4 t cos t divided by cos 2t under root cos 2t. Here also under root will come because we have taken the LCM, under root cos 2t. This is your second equation and this is your third equation. When you substitute second and third, both the denominators will cancel. So we get dy by dx is equal to dy by dt. dy by dt is this one. And denominator will cancel, only numerator will left. So we can write 3 cos square t into sine t minus 4 cos raised to power 4t into sine t divided by this value 3 sine square t cos t minus 4 sine raised to power 4t cos t. But this is not the answer. You can have to take out common terms, and after taking the common terms, you will get the formula for cos 3t in the numerator minus cos 3t, and in the denominator it will be sine 3t. So you get minus cos 3, cot 3t. Cos upon sine cot 3t minus cot 3. Okay. So this point I will elaborate more. Okay. So next page I will write the same point here. So dy, at last we got dy by dx is equal to t cos square t 3 cos square t sin t minus 4 cos raised to power 4 t sin t divided by 3 sine square t cos t minus 4 sine raised to power 4 t cos t. This was the last term. And now take it out common cos t from the numerator. You take cos t only. From the cos square t and sin t is common, correct? Cos square t and sin t is common from the numerator. So 3 is left and 1 cos t will be left. Minus 4 cos square we have taken out. So 4 cos square t is left. Correct? And from the denominator, take out common sin square t and cos t. So inside we are left with 3 sin t minus 4 sin cube t. So here cos t, cos square, cos cancel, sin cancel. So we get cos t in the numerator here and denominator sin t. Cos square t we have taken here. So 3 cos, only 3 is left here. Cos square t sin t. So 3 left minus 4 cos square t is left. Similarly here sin square cos t. So 3 is left here. Minus 4 sin square t is left here. And this cos t and sin t are left here. And here 3 minus 4 cos square t. And denominator will be 3 minus 4 sin square t. Okay. Now again multiply this cos, we get the formula. So 3 cos t minus 4 cos cube t divided by 3 sin t minus 4 sin cube t. So this is the denominator is the formula of sin 3t. But numerator will be reversed, so we have to take common minus. That means it will become 4 cos cube t minus 3 cos t. And denominator is sin 3t, formula of sin 3 theta. 3 sin theta minus 4 sin cube theta. And numerator will be cos 3t. So cos 3t upon sin 3t, it will become minus cot 3. So like this, we got this one. This one. From here to this, I have explained this one here. Okay, so that's all. We join